This is an MIT integration B question. Integral 0 to pi over 2 dx divided by 1 positive sin x. We are expected to integrate this. So for instance, what I wish to do is I would like to multiply the numerator by 1 negative sin x and divide by 1 negative sin x. So this is equal to integral 0 to pi over 2 times, or I should say 1 negative sin x with dx being placed there, divided by 1 positive sin x multiplied with 1 negative sin x gives me 1 negative sin squared x. But 1 negative sin squared x is cos squared x. So this is equal to integral 0 to pi over 2 1 negative sin x divided by cos squared x times dx. This can be rewritten as integral 0 to pi over 2 1 over cos squared x negative sin x over cos squared x times dx. Now I need to move to the next page, so let's do that. So this is equal to integral 0 to pi over 2 1 over cos squared x negative sin x over cos squared x times dx. I'm going to rewrite this as integral 0 to pi over 2 dx over cos squared x negative integral 0 to pi over 2. I'm going to write this as sin x over cos squared x times dx. Now this is secant squared x, so you got 0 to pi over 2 secant squared x times dx followed by integral 0 to pi over 2 sin x divided by cos squared x dx. Now let cos x be equal to t. If I were to differentiate this, I get negative sin x dx is equal to dt. So sin x dx is equal to negative dt. This is what we get. So I can clearly substitute this. So integral sin x dx is negative dt, so that will become positive here. I got a dt there, so this is going to be t squared, and the limits have to be substituted 0 to pi over 2. So if you were to substitute the limits, when x is equal to 0 we get t is equal to 1. When x is equal to pi over 2, this is going to be equal to 0 here. And when you integrate secant squared x, you would be getting tan x. So tan x, the limits are 0 to pi over 2. Now let me just integrate this value, find out what exactly we would be getting. So if I were to integrate this, this is going to be t raised to the power of negative 2. Don't substitute the limits as of now. Now this is equal to t raised to the power of negative 2 positive 1 divided by negative 2 positive 1. The limits are 1 to 0. Now you can either change the limits or you don't have to change the limits. So you can just retain the limits as it is, 0 to pi over 2. You don't have to give the limits for t. Now you will understand why am I telling you this. So this is equal to, if you were to simplify this is going to be t raised to the power of negative 1 divided by negative 1, which is negative 1 over t. But what is my t? My t is going to be cos x. So this is negative 1 over cos x, and I'm going to replace the limits back to 0 to pi over 2. I have just reverted the variables back to the original form. Now the reason I have done that is because of the presence of tan x here. So that is going to give us some problem. Now my main objective is to show you how exactly we can avoid this problem, because if I were to substitute tan pi over 2, tan pi over 2 will give me infinity. But that is a very difficult thing to maneuver. So having mentioned this, what I'm going to do is I am going to be substituting this value over here. So this is nothing but tan x limits 0 to pi over 2. This is going to be negative, I can take the negative sign out, 1 over cos x 0 to pi over 2, the limits. Now what is tan x? Tan x is nothing but sin x over cos x, the limits are 0 to pi over 2. Negative 1 over cos x, the limits are 0 to pi over 2. This is going to be sin pi over 2. This is cos of pi over 2, and this is the upper limit followed by this upper limit, cos of pi over 2, right? Negative, you substitute the lower limit, sine 0 is going to be 0, cos 0 is 1, so it's going to be 0 here, followed by cos 0 is going to be 1 here, so that's going to be there. Now sine pi over 2 is going to give me 1, so I have a value as 1 over, I'm not going to place the value of cos pi over 2, I'm just going to retain it as it is. So this is going to be cos pi over 2, negative 1 over cos pi over 2, right? Followed by negative negative positive 1. Now what happens here? 1 over cos pi over 2 and 1 over cos pi over 2 with a negative sign gets cancelled, giving me positive 1. This should be the answer. And I can understand your point of view that this integral looks very simple, and it is simple. But the most important part in performing this integration is applying the limits. So we need to be very careful how to get rid of this quantity tan x, and this is the way to get rid of it. Thank you everybody.